Okay, we're on the second section of the lymphatic system and our immunity. This section is going to be dealing with specific immunity. We've already spoken about innate or non-specific immunity, so we're continuing on with this this field of study. So I definitely want to now tell you all about this next most important part of our immune system, and this is sometimes referred to as adaptive immunity because it is immunity that we get after we have been exposed to specific foreign antigens, and it's our body's response to that with not taking anything away from non-specific innate immunity. I need for you all to realize that without specific immunity, we would never get out of infancy. We would never have a day in our entire lives that we weren't ill, and we wouldn't have succumbed to actual infection. So specific immunity is so it's all important, but this is so very important. And for this topic, we've got lots of information to go through. But what I'd really like to do, and I hope you'll bear with me, I'm going to use a whiteboard here to actually introduce you to what specific immunity is really all about. And I hope that you'll bear with me and that I'm using my mouse to actually draw on this whiteboard and that it will make sense for you. But let's get started, okay? Because I think that this is so important for you to know. So let's go ahead and get started. And what I want you to know is that in specific immunity, there are two components. Both of these things are happening at the same time, but because I can't talk about them at the same time, I have to take them one at a time. But you would understand that both of these things are happening at the very same time when the body encounters potential pathogens. So let's get started. So in specific, and again, forgive my mouse and not being able to do this, but in specific immunity, you have two types. The first that I'm going to talk about is called humoral immunity. Humoral immunity. Humoral, the humors of the body are the fluids of the body. So we're talking about plasma, saliva, tears, gastric secretions, all the fluids of the body, including like the lymphatic, the lymph and the lymph return that we talked about. So this is what's going on in those fluids of the body. The second major type of specific immunity is actually called cell-mediated. So first let's talk about the humoral. This is mediated, M-E-D-I-A-T-E-D, cell-mediated. But first let's talk about the humoral and what is needed for humoral immunity. What's needed for adequate humoral immunity are very special types of white blood cells called B lymphocytes. B lymphocytes. These are very, very special types of lymphocytes, and they're absolutely required for humoral immunity. When the body encounters a specific foreign antigen, and remember, antigens are proteins, and each microorganism, each microbe, and each living cell has its own unique antigenic molecules that are uniquely their own. Every species is different. When the body encounters an antigen that is foreign, and I'm just going to make up a shape of a foreign antigen. So maybe this is a little virus that has a unique little antigen that looks like this. And all of a sudden you've either, maybe it's respiratory borne, so maybe you breathe this in, maybe it's been introduced into a wound, maybe whatever, but it's foreign to the body and it's invaded into the body. You have these B lymphocytes that are going to be alerted to a foreign antigen that's never been seen before, being alerted to this, and they're going to become active. What I mean when I say that they become active is that they're going to take these B lymphocytes that are just looking for a fight. They're going to take in this foreign antigen. They're going to study this foreign antigen, and then they're going to become active and undergo mitosis. Mitosis is a type of cell division, right? When these undergo mitosis, they become very specialized B lymphocytes called plasma cells. The beauty of these plasma cells, once they're numerous, once these B lymphocytes become active and take in these antigens and undergo mitosis and then start dividing and become multiple plasma cells, it takes a little while for that to happen. But once they do that, this is amazing, because these plasma cells will produce a very special protein. That protein that they're going to start pumping out in massive quantities is called an antibody. These antibodies, which we already know antibodies are proteins, wish I could write with a stylus instead of my mouse. These antibodies, which antibodies, y'all know that's antibodies. These antibodies are proteins that are going to be directed against these specific antigens. They won't be able to work against any other antigens, but they will be specific to these antigens, and they're going to start destroying them. They're going to destroy, annihilate, take out, neutralize these antigens. And they're beautiful at doing this. As these protein numbers go up, as the amount of them go up, the amount of these foreign antigens will be going down in the system. So yes, when you first encounter a foreign antigen, these are foreign now, potentially pathogenic. At first, it takes a little while for your B lymphocytes to figure out the shape, undergo mitosis, produce a lot of plasma cells that start pumping out this protein called antibodies. But as soon as that starts to happen, the damage that these foreign antigens were doing, the signs and symptoms that you were having, that they were causing problems, they're going to start to get better. You're starting to get better. So as your amounts of the antibodies go up, your signs and symptoms of the disease are going away. So thank you, plasma cells, for producing these antibodies, which are proteins that are going to be found they're going to be released and found in the fluids of the body. And as their numbers start to go up, our signs and symptoms start to go down. The true beauty of this entire humoral immunity is that not only will the mitosis make plasma cells, but when these plasma cells are first made, there will be also a few memory B cells that will be produced. These memory B cells will last for decades. And these memory B cells, if they ever encounter these particular antigens again, even if it's 20 years later, if this thing shows up again, these memory B cells won't have to take any time. This takes a little bit of time, and that's why you end up getting signs and symptoms of disease. At first, this takes some time. But these memory B cells won't need it the next time. And so on the subsequent exposures to this foreign antigen, these memory B cells will start pumping out specific antibody immediately, within minutes. The first time, it takes some time. And in the first time, it takes some time for the numbers of the antibodies to go up. And this is why you go through the signs and symptoms of having a disease the first time you get exposed to it. Knowing the numbers, knowing how much is present, knowing the numbers, that's a number symbol, is called a titer. This is called a titer. So knowing the amount of antibodies, and you can test for the amount of antibodies that are present in serum, in plasma, in body fluids, can actually be incredibly diagnostic, because knowing the amount tells you that you're responding and that you have actually had this particular, you've actually been exposed to that particular specific antigen. So humoral immunity is all about the body's ability to produce specialized proteins called antibodies that will specifically fight against the specific antigen, which are also proteins, that are unique to each and every different species and every different cellular life form. So we have the ability to make thousands of different specific antibodies that protect us against foreign antigens. And the beauty is that after we see them the first time, we will have memory cells that are ready for them the next times, so that we don't have to go through signs and symptoms of the disease, because the next time that we get exposed, they're going to be, these B cells will start pumping out massive quantities of antibody, and I'm going to call it immunoglobulin. Immune means to protect, globulin is a protein, protective proteins are antibodies. Now, what did it take for humoral immunity? It took B lymphocytes, very special types of lymphocytes. I had kind of in hematology suggested to you that there isn't just one type of lymphocyte. There are many different types of lymphocytes. And here's the situation where you're seeing some lymphocytes are called B lymphocytes. They have the ability to become activated, undergo mitosis. The first time they're exposed, become plasma cells that put out very specific antibodies. As soon as these protein numbers start to go up, the titers start to go up, they're attacking the foreign antigens, and your signs and symptoms of the disease are going away. Thank you, specific immunity. This is only half of it. Now we have another thing that's actually happening. This is called cell-mediated immunity. We have something else that's happening at the same time. Let's go ahead and see what is happening in cell-mediated immunity. Again, cell-mediated immunity, this is the part of the specific immunity that is also recognizing a foreign antigen. The cells that are necessary for this particular half of specific immunity are actually called T8 cells. I hate to tell you all this, but this is the type of thing that happens in science where a particular cell or something has different names, but it's all referring to the same thing, the same cell. I have to give you the different names that are used, though, and you need to know them, because depending on what lab is actually reporting these numbers of these cells, you may see them written as T8 cells, but I also need you to know that these are also sometimes called cytotoxic T cells, which the C stands for cytotoxic, one word, C-Y-T, means cell. Toxic means a poisonous cell, a deadly cell, and these cells are kind of deadly, no kidding. But also, these cells on some reports are listed as CD8 cells. These are all the same thing. These are all a very special type of T lymphocyte. So I need you all to know that you may see them written as T8 cells. You may see them written as cytotoxic T cells, and usually the cytotoxic is written out as a little word T, or you may see them written as CD8. That's an 8. That's a number 8 cell on the lab report. But again, these are very special types of T lymphocytes. And T lymphocytes, we remember, were very dependent on the thymosins from the thymus gland. They're dependent on those hormones to mature. So if you don't have if you don't have a thymus that's actually working, I'm telling you that there's a very special kind of T lymphocyte that you're going to be deficient in. But let's talk about normal, because we usually do have specific immunity that's working. When this foreign antigen, this foreign particular, maybe a pathogen, maybe not too much of a pathogen, but something foreign, enters into the body, we already know that there's special kind of B cells that are going to be producing antibodies, that the antibodies in the fluids of the body can take this out. But let's look at what these cytotoxic Ts are doing. These cytotoxic Ts are going to also take in this foreign antigen, and they're going to become active from this foreign antigen, meaning that they're going to undergo mitosis too. And when they undergo mitosis, they're going to become specialized. Remember, mitosis meant cell division. It's going to be a lot of them now. Only a few get activated, but then they end up undergoing mitosis, and there are a lot of them made now. And when they undergo mitosis, they're so specialized that they're going to be hunting down this antigen, and they're going to do cell-to-cell combat. They're going to do cell-to-cell, I'm going to say combat. You know, let me tell you about these cytotoxic cells, meaning they seem pretty scary, don't they? They're only scary if they've become activated against a particular foreign antigen. I'm going to give you an analogy, and it very much is the truth about this. If you think about your specific immunity as maybe being the military, which protects, countries, right? If you think about it, the B lymphocytes are kind of like the Air Force. The B lymphocytes are the Air Force, and then they make these bomber planes, plasma cells. And those bomber planes are going to throw down bombs on the enemy. This is sounding very, very kind of like whatever. But anyway, antibodies are kind of like bombs from the Air Force. And the bombers are up in the air, and they're just making these bombs and sending them down through the fluids, if you will, as bombs to get rid of these foreign antigens. But in cell-mediated, these cytotoxic T cells, these are the Marines. These are the ones that are actually on the ground, cell-to-cell combat, taking these guys out. So you got a dual line of defense, like militaries defend, right? You've got antibodies being produced in the fluids that are proteins. They're not cells. They're made by cells, plasma cells, but they're proteins that are actually fighting against these guys, taking them out. But then you also have the Marines. You also have these cytotoxic T cells that are taking these guys out. And this takes a little while. Just like this initial exposure to the body, then the first time you ever see these foreign antigens, it takes a little while. And while your cytotoxic T cells are undergoing mitosis and building up to respond cell-to-cell combat, it's taking a little bit of time. But after there's enough of them, signs and symptoms start to go away. And they're going away because these foreign entities are being taken out by antibodies and being taken out by cytotoxic T cells. The beauty is that not only are you going to make those cell-to-cell combat ones, you're going to make some memory T cells. These memory T cells, again, along with the memory B cells, they're going to be there so that even if it's 3 decades later, you encounter that same foreign antigen, this memory T cell will live for decades, and it's only looking for that specific antigen. If it ever sees that specific antigen, that protein that was foreign, that it remembers, it's going to be able to fight immediately. It's going to combat this immediately. These memory B cells are going to immediately make antibodies, start pumping it out in huge amounts so that the antibodies can take this out. So in your specific immunity, you have two arms of it that will start to work whenever foreign antigens are encountered in the system. Now, I'm making it sound like foreign antigens are always horrible and foreign antigens always cause signs and symptoms of disease. Sometimes they don't. Sometimes they're just things that are in your ecosystem that are, because we live in a foreign ecosystem. The only thing that's self is our own cells. But we have to have this immunity that is actually recognizing foreign info. And most things don't really cause you to have any signs and symptoms of anything, but you still built this response. And as long as you have the memories, they're never going to cause you any trouble, even if they did initially, even if it was something that caused you trouble initially, like common colds, all kinds of infections that you can have. It's not going to cause you trouble usually the next time. Now, if the antigens are not stable, if there's and I'll give you an example of this, like the influenza virus. Influenza viruses change their antigenic structure. They evolve quickly and rapidly. And because they do that, because they've changed their structure, every time you encounter them, you have to go through this initial response. And this is why you can get influenza over and over, that particular disease from influenza viruses over and over again, because the antigens are changing. So just to sort of give you that heads up, again, I want you to know about humoral, involving B lymphocytes and antibodies. I want you to know about cell-mediated, involving cytotoxic Ts and cell-to-cell combat. I want you to know that both divisions produce memory cells so that you don't have to do it the second time, and that typically, especially for things that have very stable antigens, antigenic determinants, you don't get those diseases again. You don't get them but once. It's why we can spend many days of our lives not being ill. Otherwise, every new thing that we ever encountered, and even old things that we encountered, we would be responding to. We would never get out of infancy. We would never have a day of wellness. If it weren't for specific immunity, we would never have a day of wellness. Now, that's beautiful. But I need to tell you about some more cells. In specific immunity, you might be wondering, okay, well, how do we ever know? Like, what alerts us that there were these foreign antigens that entered? Maybe they entered through your eye because you rubbed your eye or you rubbed your nose and that was enough. Maybe you swallowed some viruses that can cause, or things that can cause, like food poisoning or gastroenteritis, whatever. So how do you know when something is foreign? We have another special type of cell in specific immunity that actually is the alarm for when something's foreign. Those cells, and again, it's not my fault, but those cells, and I'm only talking about one kind of cell, but it has different names that's still referring to the same cell. And depending on the lab, again, it will be sometimes called a helper T cell. This is a little h of T cell. Sometimes this cell is called a T4 cell. On lab reports, sometimes this cell is called, a CD4 cell. I actually think that's weird. That's supposed to be a C and a D a C and a D4. Most labs call these CD4 cells. Most labs call these CD8 cells. But I can't guarantee it. They may actually call them helper Ts. But these are all the same kind of cells. So I'm talking about one particular type of T lymphocyte. So these are different lymphocytes. These are different lymphocytes than these, and these are different lymphocytes than these. These helper T lymphocytes. Let me tell you about these helper T lymphocytes. They almost got no recognition until the 80s, 1980s. I mean, they really didn't, because it wasn't really well understood before then what they were really doing. But what we know is that your entire specific immunity hinges on these guys. Because it is these special kind of T lymphocytes, the CD4s, the helper Ts, that actually alert humoral immunity and cell-mediated immunity cells. They do it by secreting these chemical signaling molecules that actually are going to be sent to activate the B lymphocytes. They're going to be sending these molecules to activate these CD8 cells. Without these helper T cells, these two things don't happen. Oh my goodness. So please know about these cells. Another important reason to know is that we know there's a virus that actually attacks these cells. There's a virus that attacks these particular cells. It doesn't just attack these cells, but because it attacks these cells, we know that this virus absolutely destroys our specific immunity and cripples our specific immunity, crippling these two. That virus is HIV, Human Immunodeficiency Virus. It attacks these cells. And so this is why that particular virus is so devastating to our immune system, is because it actually takes down the numbers of these cells that we need. If we should have a minimum of 600 of these cells, a minimum, per microliter of blood circulating around of these specific T lymphocytes, the helper Ts. Once that number goes below like 200 cells per microliter, the helper Ts get that low, you're said to be in full-blown AIDS. AIDS stands for acquired, because you acquire the virus. It's an infectious disease. It's not autoimmune. It's an infectious disease. It's a virus. Acquired immunodeficiency syndrome, AIDS. AIDS is caused from a virus called the Human Immunodeficiency Virus. And the reason that that virus is so devastating to the immune system is that it specifically attacks these very important helper T cells that our entire specific immunity hinges on. So this is why that's so devastating. Now, there's another type of T lymphocyte. You're kidding me, right? No, I'm not kidding you. There's another type of T lymphocyte, and these are called the suppressor, y'all write that down, suppressor T lymphocytes. What I want you to know about suppressor T lymphocytes is that they sort of monitor this whole system, the humoral and the cell-mediated, making sure that it stays in the right kind of response. You know, just like a military, you wouldn't want them to blow up entire, you don't want to blow up an entire city just to maybe take care of a couple of bad guys, right? You want it to be measured. You want this entire response to be a measured response. You don't want too much collateral damage being done to your own tissues, do you? You don't want too much damage being done to your own tissues. So these suppressor Ts are going to monitor this response and make sure there's not too much collateral damage. Because your immune system can sometimes be over the top. You know, we will learn when you all take microbiology and, you know, you get deeper into this, you'll learn that there's a few ways that infections actually can cause damage. Sometimes infections cause damage because the bad guys themselves are producing toxins or enzymes that are damaging your tissues. But sometimes the way they cause damage is that your immune response is over the top, and there's all this collateral damage that's happening because of how much the immune system is doing. So when things are working as they should, the suppressor T cells are keeping that from happening. I want to let you know that in recent research, we realized that in autoimmune diseases, where the immune system has started attacking your own tissues or causing damage to your own tissues, it's actually being thought that the suppressor Ts are maybe not doing what they should be doing. So some of the newest research is actually is targeting whether that's the case, whether the suppressor Ts, there's something going on with the suppressor Ts not limiting the response the way that it should. These responses are wonderful. Usually they work just right. And again, allows us to get out of infancy and allows us to have days that we're well because we have memory of things and we don't have to keep continuing to actually get sick and get over things. These all work. But I hope this, okay, now this whiteboard looks a little crazy even to me, but I hope you all were following along with this. I hope you understand the two branches of the specific immunity. I hope you understand specifically which cells are involved in each of them, and also the cells that the entire thing hinge on, which are those helper CD4 cells. I hope you understand that the suppressor T lymphocytes limit and monitor the response and make sure it's okay, that the response isn't over the top, and that there's going to be collateral damage to your tissues while we're trying to take out just the foreign antigens. And this is called your specific immunity. Now, I also, just the analogy again for you, is if you think about this as like military, these helper T cells that are actually going to start the whole process of recognizing that there's a foreign antigen there and that we need the B lymphocytes, the Air Force, producing bombs, antibodies, and that we need the Marines doing you can think about the helper Ts as being like the Pentagon, right? But then you can also think about the suppressor T lymphocytes as being the internal affairs, making sure that the Air Force doesn't get too crazy and bomb too much, and making sure that the Marines are doing what they're doing and not going over the top. So it's just an analogy to show you what goes on in your body with the specific immunity. I hope that kind of helped you to see about the specific immunity and what cells are involved in it. Now, I want to talk to you now about antibodies, which we know are proteins. They're not cells. B lymphocytes are cells. T8, CD8 cells, cytotoxic T cells are cells. Suppressor T lymphocytes are cells. Helper T CD4 cells are cells. But antibodies are proteins. Antibodies are proteins that are going to be made in response. Specific shapes, specific structures that are made in response to being exposed to foreign antigens. You all have heard about antibody-antigen reactions before. You heard about naturally occurring antibodies, which are actually kind of rare. but you heard about naturally occurring antibodies that occur in response to ABO inherited blood antigens. So, and when you were hearing about those, you've already gotten a heads up that antibodies are proteins that actually can attack, annihilate, take out, destroy, neutralize specific antigens. Okay, so you've heard about that before. Now I want to talk more about these memory B cells that produce immunoglobulin, but I'm going to go back to my specific immunity for a second for that. So antigens, we know, are proteins that are unique to each different living types of cells and structures. But antibodies, classes, there are 5 different types of classes of antibodies. What I was just explaining to you in specific immunity on the first exposure, on the initial exposure, where plasma cells actually start pumping out antibodies, was a class called IgM. And I need you to know that that's the class for the initial exposure. They're the ones when you first encounter will actually be made. On subsequent exposure, on the secondary, tertiary, the however many times in your life you get exposed to it again, these are called IgG. Ig stands for immunoglobulin, immune protection, globulin protein, protective protein, antibodies. This class G, this is the majority. I need you to know it's the majority. It would make sense that it's majority because these are the ones that you have memory to. So you have thousands of memory B cells that are making this class of antibodies. These can cross the placenta, so they can protect fetuses. If a woman is pregnant that has had antibodies to rubella, measles, rubeola, anything, mumps, if she's pregnant and already has antibodies to these, it won't matter if she encounters it while she's pregnant. It won't hurt her fetus because her fetus is protected. Now, if she doesn't have them, if she doesn't have antibodies, and she ends up getting measles, mumps, rubella, chickenpox while she's pregnant, and she doesn't have protection, that virus is one of the ones that can cross the placenta and be devastating to a fetus. So let's think about this again. So antibodies that are circulating in like a pregnant woman can actually be very protective to a fetus, right? This is the class that is the predominant class. This is the class that is on the secondary exposure, and that's important. I'm going to show you why in a second. There's a class that's slightly different, and it's just about their structure that's different. You don't need to be able to draw them. I just want you to know that we can actually order them on test. We can order to see if somebody has IgM. We can order to see if somebody has IgG. We can see their titers. We can see how many they have, how much they have of it. IgA is going to be found in saliva, tears, breast milk, intestinal secretions. This is a class that is going to be found in those different types of serous fluid secretions. IgE is a type of antibody that we see in allergies go up. If somebody's having allergic reactions, hypersensitivity reactions, where they're secreting histamines, it's going to be a titer of IgE. So if you suspect someone to have allergies of a particular thing, all you have to do is order this test. If the titers are high, there's your answer. If you suspect that someone has signs and symptoms of a disease and you've given them long enough, because remember, it takes a little while on the first exposure, doesn't it? It takes a little while. But if you've given them long enough and you look for titers of IgM for that particular disease, that specific disease, and it comes back positive, there's your answer. That's your answer. That's your diagnosis. That's your definitive diagnosis. If you're seeing if somebody has already had, maybe it was years ago, but somebody has already had, if you're looking to see if they've ever been exposed to a particular antigen and they had it long ago, order an IgG titer. And if that's positive, there's your answer. Yes, they had. They've been exposed. They had it. They've already had it. So what I'm telling you is that if you understand these classes, I'm not going to ask you about D because that's never used for diagnosis. But what I'm telling you is that if you remember these, and you will need to, well, you'll need to from me because I'm going to ask you about them. I'm going to test you on this. I'm going to ask you specifically about these classes because they're diagnostic. But if you know them, then you really truly can use them to get titers to diagnose disease. And that's incredibly important because without definitive diagnosis, we're working in the dark. We don't know what we're treating. We're trying to, treat everything. And a lot of times when that's happening, the treatment sometimes is worse than, the cure is worse than the disease. So getting to a definitive diagnosis is everything. And we can get to them oftentimes by looking for antibody secretions. I want to tell you that serology is the study of serum. Serum is, I had defined that for you. Serum is actually the part of plasma lacking blood clotting factors. But serum and plasma, body fluids, where we know antibodies are found in body fluids. There are two types of serology tests, two major types. One is called a direct serology testing, and the other is called indirect serology testing. I need you to know that an indirect serology test is looking for antibodies. A direct serology test is looking for the antigens. So depending on what is being presented to you and the patient, it might be that you want to do a direct serology test. And here's an example of, just one example of many, but here's one example of direct serology. You have a person who's just started with signs and symptoms of a disease, and let's say it's a very sore throat, let's say it's fever, let's say it's body aches, let's say it's nausea and headache. Very sore throat. You look at their throat, and their throat looks like it has, and this is called, sore throat is called pharyngitis, inflammation, pharynx of the throat. And you look back there and you see pus pockets. So here's the thing. They just started with signs and symptoms a day ago, not even maybe. And you need to figure out what this person's dealing with. Do you want a direct serology test where you're looking for actual, like ruling out strep throat? Or do you want an indirect serology test where you would be looking for a person's response to it and their production of their own antibodies to it? Well, in that case, you would be wanting a direct serology test because you're going to take a swab, go back there and touch a pus pocket, if you can, the back of their throat, and you're going to be looking for Streptococcus pyogenes. You're going to be looking for the antigen, the bad guy. That's when you would want a direct serology test. But sometimes you're not going to always be able to do that. So you're going to end up and there's some diseases where it's really hard to find the bad guy. An example of that is HIV, actually. That virus can be in such low numbers, the bad guy, the antigen itself, in such low numbers that the sensitivity of the test is too low to do a direct. It can often be too low. So the first thing that you're going to be able to detect is actually going to be the antibodies. If somebody has made antibodies to a particular foreign antigen, they wouldn't have done it unless they've been exposed to it. So if they have antibodies, that test is just as valid as a direct serology test where you're actually finding the antigen. I hope that makes sense. So again, I'm letting you know that sometimes you'll want to order a direct serology test looking for the antigens, looking for the bad guy. But sometimes that's not always possible. It's not. And so you're going to have to then be looking for an indirect serology test to give you the answer. The indirect serology test is looking for the antibody classes. And it might be, if you think it's the first exposure and they've been sick from it, it might be IgM that you're looking for. And again, if that's coming up slowly, then there's your answer. That is definitely what they had. It might be that they have IgG, which meant that they'd had it in the past, and you're not sure when they had it, but they'd been exposed to it in the past. I want to show you a picture. And I'm going to get to it. A lot of these. Here's a great picture. So on first exposure, when the person's sick, it can take days before those plasma cells start pumping out the first class of antibody responding. But look at the memory B cells. The memory B cells on re-exposure, and I don't care if it's decades later, those memory B cells within minutes of seeing that foreign antigen for the next time, they will be pumping out. Remember, titer tell you how much. They'll be pumping out huge amounts of that antibody. It will be flooding the systems. Bombs will be going off everywhere for those antigens. And you will be taking those antigens out. You'll be taking them out so quickly that you will never get signs and symptoms of the same thing twice. Now again, there's some things that are evolving and their antigenic structure changes enough that you can get those particular diseases more than once. But for most things, you don't. And again, for most things you don't, because you have memory. You have not only memory B cells that are pumping out these huge amounts of antibodies in a quick little period of time. I'm talking about minutes on re-exposures. But you also remember, don't forget the Marines. You have memory cytotoxic T cells that are also ready to start fighting cell to cell against those particular antigens. So I think these pictures are just reiterating what I did on that little whiteboard, but I definitely want you all to go back and make sure you have a this talks about the helper Ts, make sure that you go back and you have a very good idea of how to explain the two arms of specific immunity, humoral and cell-mediated, and that you know which cells are unique to each of them, and you know what the functions of those cells are. So that's going to be important. Cytotoxic Ts, as I said, are no joke. These guys talk about Marines and hand-to-hand combat. They're ready for it. If you look at even cancer cells, the cytotoxic the T cells are much smaller, but they obviously don't know it because they can destroy those cells. We have throughout our lives as organisms, we have cells that are cancer cells all the time that are happening. But that doesn't mean we have cancer from the very beginning, whatever, because they're getting destroyed. They're getting destroyed because of strong immune systems. So that's going to be an important thing for you to see. They produce little products that actually are going to destroy those cells. Now, I had talked about suppressor Ts too, and playing a role in helping to prevent autoimmune disease, because suppressor Ts are limiting the collateral damage that are going on when all this combat is happening in the body. So please know that as well. And we do have memory. I'm going to want you to also know about passive versus active immunity. And the best way to describe this is an active immunity, you're making your own antibodies. In active immunity, your immune system is responding itself. In passive immunity, you're getting protection from somewhere else, from outside. So in like natural active, it means that you have actually encountered the foreign antigen, and you probably had the disease. Or most things don't ever cause us to have noticeable signs and symptoms. We don't even have noticeable signs and symptoms, but we produced our own memory B cells and our own memory T cells, and so now we have natural exposure. In artificial active, it means that you got a vaccine. When you got the vaccine, your body went through and still made its own response, and now you're protected going forward. What a beautiful thing immunizations are. And, again, you learn about this in microbiology, but, if you just looked at measles used to kill millions, up to 6 million, and it was mostly children, a year before vaccines. I want you to get your head around that, okay? Before immunizations, the childhood immunizations, it was a 50-50 chance your child would make it to 5 years old. 50-50. Now, that's something that modern people can't get their heads around, and modern people also have like no memory of history. I mean, that's the only explanation for why people don't get their kids immunized, is that they don't understand recent history. But just looking at one disease, measles. Now, there's still a lot of children die from measles that don't get immunized, but not like it used to be. So the beauty of immunizations is that the person doesn't have to have the disease the way that they did up here in natural active. I have immunity to measles because I had measles. This was before immunizations. I had it. Yeah, I'm that old. And I survived it. Not all did, but I did. And so I have natural active immunity to that. But measles hurts. It can actually hurt your immune system for a couple of decades, even if you've survived it. So it's one of those we used to call childhood diseases that you don't want to have if you can help it. And now we have immunization, so you would certainly choose that option. Anyway, so that's our artificial active. And the kids that get immunized, they're making their own memory cells to it. And these are the ways we can be protected. Now, in passive, that's very different. In passive, you're not making your own response. You're getting it from outside. So a perfect example of natural passive is the fetus. I told you that a mother's IgG class of antibodies can cross the placenta and protect the fetus. And even when the fetus is born, those IgG antibodies from the mother will last for a few weeks. Now, they won't last forever. They're just proteins. They're going to break down eventually. And then the fetus is going to be having to make their own response. Well, now it's called a neonate. Neonate is in the first few weeks, or it's going to have to make their own response. But for the first little while, a fetus can actually be protected from the mother's IgG antibodies. Now, the fetus can also be protected from the IgA antibodies from the mother's breast milk. So breast milk is rich in IgA, maternal IgA antibodies, and those antibodies coat the neonate's GI tract and can really protect that neonate from being susceptible to having dehydration in those first few weeks of life. This is why it's really, if possible, it's not always possible, but if possible, even just getting the first milk, which is called colostrum, it is so rich in maternal IgA antibodies, it's really recommended that even if you just breastfeed the first few days, it can really protect the neonate for weeks after that. So that's natural passive immunity. But there's also something called artificial passive. And this is where if you get exposed to something that we know has an incredibly high mortality rate, like, well, rabies is essentially 100% mortal, fatal, or tetanus going untreated could be, or certain antivenoms, and even hepatitis B virus. If you get exposed, they're going to give you immunoglobulin just as a shot to just help boost your protection and get you through. Because if they artificially give you that immunoglobulin, which is just protein, it's going to seek out these antigens, and it's going to seek out and take them out and help to protect you. So this is temporary, though, just like natural passive is temporary. So passive is temporary. All right, so that's the difference in those two. active versus passive. Make sure you would kind of know some examples of that. Now, that's wonderful. What we just talked about is our immune system. Non-specific, innate, things you're born with, and then specific, which is adaptive, meaning that you had to be exposed to mount a response. You had to adapt to what you were responding to in these foreign antigens. So I hope you've learned a lot in those particular situations. And I hope you've also have an incredible respect for your immune system and keeping your immune system strong. Now here's what this last part of this chapter is talking about: when the immune system goes awry. And when we're talking about immunology, the study of the immune system, we look at what's normal, which we just did spend time looking at, but you also look at disorders, and some of the disorders are a hyperimmune response, too much, hyper too much, and some are immunocompromised responses. So let's take a look at the basics of, first we'll look at hyper responses, hypersensitivity responses. There are actually 4 types of too much of a response. The first type is what you call allergies, and this is by far and away the most common. So allergic responses. To be honest with you, we really should never have allergies to anything in our ecosystem. I mean, we're supposed to be able to live in our own ecosystems without being sick from it. But so when we are having allergies, it means we're really sick of our environment. Our environment's making us sick, which is unfortunate. But most of you know somebody with allergies, and when this is actually happening, this hypersensitivity, it is due to allergens. Allergens are really anything that can cause an allergic response. These allergens are actually antigens, foreign antigens, that, it can be anything from ragweed, pollen, dog dander, cat dander, dust mites, anything. It can be those things. And they can cause localized responses, which are annoying, like runny eyes, noses, da-da-da. Or it can actually sometimes be systemic. And if it's a systemic response, especially to the airways, this is going to mean that it can lead to dangerous, life-threatening situations, because the airways will close down. And if that happens and you can't move air, then it can lead to shortness of breath, difficulty breathing. Dyspnea is difficulty in breathing. And this also at the same time is causing capillaries to dilate, which is decreasing blood pressure. It's causing capillaries to be leaky, which is meaning the fluid from the plasma is leaking out. That's decreasing blood volume, which is decreasing blood pressure. So that's a double whammy to blood pressure, taking it down. And this can cause you to go into anaphylactic shock. So, which is a life-threatening event and requires immediate, when I'm talking about immediate, I mean minutes mattering to save lives here. I need you to know that asthma is actually a hypersensitivity disease, and it is a disease that you do not outgrow. If somebody actually has asthma, I know there are a lot of people who say they were told they had asthma and that they outgrew it, but that was really kind of a misdiagnosis in the beginning. Sometimes you can have allergies and allergens that you do outgrow, and it's because your body converts from IgE class of antibody that causes you to have those reactions to IgG. And IgG means you're never going to have reactions again. What we would love is to have everything be IgG, because it means those antibodies, you're never going to have reactions again. And some people really do that with certain allergens when they're really, really young. But if you truly have asthma, which is reactive airway disease, and it is a life-threatening disease, and you do not outgrow it, it means that forevermore you should always carry rescue inhalers and inhalers that can help you through a particular crisis. because you don't really know when you'll encounter these allergens. And it can be when you least expect it. If you are not prepared, then minutes count. And I'm going to tell you, and maybe you'll remember this, and I hope you don't have to remember it and you won't ever think of me again when you hear this, but the people who die from asthmatic attacks are the mild asthmatics, the ones who are, they didn't have their inhalers. Because they thought they'd outgrown it. They thought they didn't have it anymore. They thought that they weren't going to have a thing. People who have serious asthma, they don't go anywhere without their inhalers. They don't. And I need for you all to stress this to your patients, that there's no such thing as mild asthma. There is no such thing, beast. Every single asthmatic event is a life-threatening event because the airways are closing down. And if you don't have serious, confident medical intervention within minutes available to you, you're done. And I have seen personally in the ERs a couple of young people come in that didn't make it. They made it to the ER, but they were already so far gone, there was no bringing them back. And if they just had rescue inhalers on their way in, or where they were when it started, it would never have happened. The loss of life would have never happened. Again, there's no such thing as a mild asthmatic. Let your patients know that if they have asthma, they need to always have in-date, available, readily available rescue inhalers with them all the time. All the time. All right, and it's because of a hyperimmune system that closes off those airways, causes those bronchioles to constrict, closing them off too quickly. All right, type 2 are examples of like transfusion reactions and complement issues. Type 3, another type of that. You know, some of these are related to, I do want to tell you about acute glomerulonephritis. And I'll write that down, acute glomerulonephritis. And I'll break it down for you, okay? Acute means that the signs and symptoms come on quickly and they're serious. That's what acute means. Signs and symptoms come on quickly and they're pretty serious. Itis meant inflammation of. Nephron means kidneys. And glomerulus are the filters of the kidneys. So signs and symptoms are serious, and it's inflammation of the filters of the kidneys. Okay? Now, when we see this is post-streptococcal infections. So let me say that again. Post-strep throat is when we see this. Sometimes we see it post, like impetigo. Impetigo is a skin thing that's from Streptococcus pyogenes too. By the way, if you've ever known anybody or you had strep throat and you got treated with an antibiotic for strep throat, they were not treating your sore throat. Your sore throat was not going to kill you. You were going to get over your sore throat, most likely. Your sore throat was not, I know it hurt your feelings and it made you feel bad, but that's not why you got the antibiotic. The reason you got the antibiotic was to prevent this. And to prevent, and it's not on here, but to prevent rheumatic fever. Because in some rare case, it's pretty rare, but it's still rheumatic fever, which is, again, one of these hypersensitivity things, post-streptococcal infection. That was one of the leading causes of death in children before antibiotics. Again, get your head around that. But on rare occasions, when someone has strep, because Streptococcus pyogenes pharyngitis is very, very common, on rare occasions before antibiotic use, the immune system response was so over the top, hypersensitive, over the top, that these antibody-antigen complexes could shut someone's kidneys down. Shut them down, the kidneys down. Completely block the filters of the kidneys. So urine output decreased, and not only decreased, but start looking like black sludge, the urine did. Because remember, the kidneys are just filtering blood plasma. But the blood plasma now has so many antigen-antibody complexes that it's so thick that as blood is trying to be filtered in the kidneys, it's blocking those filters and causing inflammatory response that's shutting those kidneys down, and you can lose your kidneys. And it happens quickly. If this starts and they don't block it, quickly block it by doing dialysis and doing serious medications, then the kidneys will be lost, and that person will have to go on permanent dialysis until they have a kidney transfusion, and or the person might not make it anyway. It can do the same to the heart valves. So rheumatic fever, which damages the heart enough that the person might get through the initial bout with rheumatic fever, but it weakens the heart muscle so much and the valves that this usually leads to an early death. So rheumatic fever, acute glomerulonephritis, these are all sequelae, which means sequential things. Sequelae just means something that happens after the initial disease. So this is why they treat you when you have a strep throat, not because your throat's sore. And don't be so afraid of strep throat now, because it's only a few that would ever this would end up happening to. But we treat them all just to cover these few that this would happen to. Again, infections it's not always the initial thing, the reason that you're treating it. Sometimes you're treating it because of what the immune response would be if you didn't treat it. Lupus is another one. Another type of autoimmune disease that happens because of interference with reactions from something mild is like type 1 diabetes. That's a cross reaction. You have this, like with lupus and with type 1 diabetes, type 1, you've had this mild virus that probably didn't even cause you to be very sick, but you had it and you made antibodies to it, and those antibodies cross-reacted with your own tissues. In lupus, it's going to be against your connective tissues. In type 1 diabetes, it's going to be against those beta islet cells of the pancreas. So these four classes are all related to your immune system being too much. And actually, we do know about them, and we do know it can actually happen. So we look for them. We look for these types of things to be happening. There's also delayed hypersensitivities that can happen. This like poison ivy, poison oak. Sometimes people react to latex, to powders, to cosmetics, to whatever. It causes a delayed reaction. This involves what are called haptens, which are actually molecules that don't really act so much as allergens by themselves. They're too small to cause that kind of response by themselves. But in some people have proteins, their own natural proteins, that will act with these haptens, and then it will be a delayed response that happens later. But again, they can cause localized actual issues, and those localized reactions, dermatitis, and those types of things can be pretty serious depending on, just how invasive they can be. So autoimmune diseases is when your own immune system attacks your own cells, self-antigens. It can happen because of cross-reactivity, like I just suggested with that you got a virus, you made an antibody to it like you were supposed to, but your antibody structure was so specific that it actually started interfering with your own self-antigens. Or it can be an abnormal exposure to self-antigens or a change in your self-antigens. Remember, our plasma membranes are constantly evolving, and our plasma membranes are constantly putting up, we learned this in AP1, are constantly putting up new proteins, and the proteins are what help the plasma membranes carry out functions. So when you start making self-antibodies, that's not a good thing, because we know antibodies do seek out, destroy, annihilate, and whatever. And we usually think of that as being a good thing, but not when it's against your own antigens. Now, these were 4 different classes and you don't need to know which class is which, just, realize that this is what can happen. These are the things that can happen when your immune system is over the top, working, to actually now it's hurting you instead of helping you. But you can also have immunodeficiency disorders. And there are two types of immunodeficiency disorders, and I don't think they're listed here, but I'm going to tell you there's primary immunodeficiency disorders, and there's something called secondary immunodeficiency disorders. Primary immunodeficiency disorders are inherited. So they're inherited immunodeficiencies. So you didn't inherit the recipes for those complement proteins I talked about. You didn't inherit the ability to make specific types of antibodies and or immunoglobulins and or interferons. You didn't inherit a thymus that's working like in severe combined immune deficiency syndrome. So you didn't inherit the ability to mature your T lymphocytes. In that case, you're going to be put in a bubble, and that's actually really what these babies were called, bubble babies. It's usually sex-linked. It's usually more males than females, and they never came out of a bubble. Now with stem cell replacement, they're actually having some success with through genetic engineering and allowing this rare, thank God it's rare, case of when the severe combined immune deficiency syndromes happen. But these are in primary or inherited disorders, and it might be something really minor. It might be something so minor that you're lacking a particular protein, like one of those complement proteins, that you don't really get a true diagnosis until you're an adult. And then when you get the diagnosis, you look back and think, well, that completely explains why, I had so many opportunistic infections, and, this person's was weaker than their immune systems were weaker and got sick more than anybody else did. So some of them are kind of minor under the radar, and then some are severe. Okay, so that's primary. Then there is secondary immunodeficiencies. Secondary immunodeficiencies are acquired. This one that you hear the most about, because it's still in the top 3 causes of death, is acquired immune deficiency syndrome. Everyone should know exactly what AIDS stands for, and everyone should know, because it is a leading cause of death in the world today, and everyone should know exactly what HIV stands for. That's the name of the virus that actually can, not always, but can lead to the disease we call AIDS. Not everybody who is HIV positive will progress to AIDS. Some people with proper treatment now, and this is really wonderful news, with proper treatment now, people who are HIV positive, if they detect it early, and if they have treatment that's as they're supposed to, they can lead and live relatively normal lifespans. So we've come a long way in understanding this virus and really even how to control the virus. Unfortunately, we haven't gotten a vaccine that's been effective against it. This is one of those viruses that are evolving. It changes antigenic structure. Even within one patient that's HIV positive, they can sometimes have a couple of different serotypes of the virus. So this virus changes, but I think we're close to getting an immunization. Now there's new technology for immunizations out there and vaccines, and so I think we're actually getting closer and closer to that. But there's also advancements that's been in treatment and trying to block the virus and how it absorbs, and blocking how it replicates inside of the host cells, and supporting the person surviving even with HIV positive status. So we understand that that is a secondary type of immunodeficiency disease. There are other things that can actually, other viruses that can actually weaken your immune response that are secondary, but HIV gets a lot of attention because obviously it is so prevalent, and it actually is still in many areas is fatal and can cause issues. This particular virus is not easily spread. It's not easily spread. You have to have direct fluid contact, and it's not in all fluids. It's not in all fluids in high enough numbers that all fluids can transmit it. Like, it's not high enough in saliva to be transmitted, but there's a lot of it in breast milk. So women who are HIV positive would never want to breastfeed a fetus, because if they actually delivered a fetus, a neonate, with their HIV positive status, and the neonate happened to be HIV negative, it isn't always transmitted. Without treatment, though, there's a higher probability it will be transmitted to the fetus. But if a woman who is HIV positive gets treated during her pregnancy, the risk of it being transmitted to the fetus goes way down. But then they deliver the neonate. They would never want to breastfeed because it's so high in breast milk. Do you get what I'm saying? There's certain types of sexual encounters that make it a higher risk of transmission. So anytime there are membranes that can be broken and there can be blood transfer, there's going to be a higher risk of transmission. In those cases, there's certain groups of people who, demographics that we see the numbers increasing most in. And so all of that information is really important. It's all involving epidemiology, which is the study of disease. And in this particular one, we know a lot about how HIV is transmitted. And we know which groups are most at risk right now. And so sharing that information is really very important. I had talked to you about the idea that this virus attacks these helper T cells, and that once they go below 200 cells per microliter of blood, you're now considered to be in full-blown AIDS, which means that you're going to be at risk for dying from opportunistic diseases. And you should know that an opportunistic infection means that it's something you would have never had unless your immune system was compromised and it was given the opportunity. By the way, you'll see some of the things that AIDS patients die from. They die from pneumocystis pneumonia. They die from herpes encephalitis. They die from Kaposi sarcoma, tuberculosis, toxoplasmosis. They die from these things that you don't see people with strong immune systems dying from or even getting disease from. That's what an opportunistic infection is. They do not die from the virus, HIV virus. HIV virus just attacks the cells that they need to protect them from these other things. Do you hear what I'm saying? So HIV virus doesn't kill anyone, but because it's crippling their immune system, then these people end up dying from other infections that shouldn't be causing them to die, but they die from those if they go into full-blown AIDS. But again, now there are people with HIV positive status with proper treatment that never even go into the AIDS-related complex. I mean, they end up, this is an early signs and symptoms, but they don't do this, nor do they go into full-blown AIDS, because they're controlling their viral load, which means they're controlling the amount of viruses present that becomes even undetectable in direct serology testing, where they're looking for the direct antigens. Doesn't mean that they don't have HIV anymore. They don't have the virus. They do. Doesn't mean they're not contagious. They are. They would still need to protect, to not spread it. But it's so low that it is not affecting these numbers of helper T cells, so their immune systems can stay strong. I hope that made sense. I'm sorry that And again, these treatments, some of this is even old now. They have newer treatments even than the triple cocktails, but we call these the triple cocktails that people were given for so long. So lots of new treatments for HIV and actually lots of good news for that particular disease, but still prevention is everything with infectious disease. So guys, this is the lymphatic system. Thank you for looking at these two recordings. I know there's a lot of information. I hope that you found it fascinating, because your immune systems are fascinating, and understanding disease is you would have to have a good grasp of this. So anyway, I'm sorry I wasn't with you, but when the next time we are together synchronously, you'll be able to ask questions about this, okay? And everybody take care, and I'll see you in the respiratory system when we're talking about the respiratory system.